Assuming you've read through the online textbook and perhaps poked around through the online material a little bit, you should be familiar with the term chair conformation, referring to the lowest energy conformation that a hexane ring usually takes. In this video, we'll be going over how to draw chair conformations, identifying positions on the chair conformation regarding atoms that are connected to these carbons in the hexane ring, as well as trying to visualize what a chair flip looks like. And no, it's not physically flipping a chair, but you'll see what we mean. To begin, let's go ahead and draw a chair conformation. I usually start with something that looks a bit like a shark fin, or more of a side fin perhaps, I'm sure you know what a shark looks like. Then I draw two parallel lines emanating from the endpoints, like this and like this. And keep in mind that they're going to be the same length, but the one on top will go farther to the left because of the angle. And then we draw essentially another shark fin, which is going the opposite direction, like this. And you might notice that there are three sets of parallel lines if you draw the chair conformation perfectly. That would be here and here, here and here, and here and here. So attempting to visualize those parallel lines as you're drawing can help you get in the habit of drawing chair conformations without a problem. Now we want to identify the positions that atoms connected to these carbons in the hexane ring take in a chair conformation. Now, in this case, since we're working with just a hexane ring, all the atoms in these positions are hydrogens. So I'll just go ahead and draw a line to represent these bonds. There are two types, axial and equatorial. Axial means, in this case with the chair conformation, bonds that go up and down. And we'll go ahead and go through all of them. There's one here, 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 and here. And as you can see, the axial bonds go in the direction of where the arrows point in a way. For example, if you consider this an arrow, it points up, and thus the axial goes up. Same thing here, where a shark fin, as we mentioned earlier, points down, the axial points down as well. Equatorial, on the other hand, implies that the bonds are going out, away from the molecule, in a sense, and we'll use another card to illustrate those. That would be here, I'll connect that, here, 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 and here. With the equatorial positions, it can be a little difficult to get the bond angles right between the equatorial and the axial, so just be looking for this angle right here in all of them. That way you can practice positioning them in the right place. In all honesty, it's not paramount, but it's good practice for achieving good-looking chair conformations. Not to mention, you'll want to be able to identify these positions easily, because when you have other carbons like bromine, chlorine attached to the hexane ring, that's going to affect how the chair wants to be, and that's where we're going to move into chair flips. And in the next video, we'll talk about how you decide between chair flips once we define it. As you can see here, I've drawn a relatively large chair conformation, so we can start talking about what a chair flip looks like. I've always imagined this, and I've even demonstrated this in tutoring with a piece of folded paper. And what I did was cut out a hexagon, thus like a hexane ring, and I folded it along two lines. And the lines I'll show with the dotted line here. The folds were here and here. So you can imagine this end pointing up and this end slightly pointing down. Now the chair flip happens when we take those folds and we put them the other way around. So on the right, instead of going up, we grab it and pull it down. And as for the one on the right, we grab it and pull it up. So if I were to draw that below, what that would look like would be something like this. Now, I'm not the best at drawing it in the other way, and it's almost in a way that I'm so used to drawing with the right hand and whatnot, but you can see we can identify the folds, in a sense, and see how the chair is flipped in a way. And I've always, when we have said chair conformation, you can imagine, I guess, a stick person lounging in the chair and whatnot, and the chair is just flipped, as opposed to a person, lying here, and I guess they have really flexible backs and whatnot. But here's how you can imagine the chair flip, almost a lounging lawn chair, if you might, and we just flip along those ways. But later on in the next video, I'll show you another way you can do chair flips without having to think about it as much.